Very good evening, student. Today we will be looking into task number 5, that is Tessent compression, that is EDT, embedded deterministic test. So in the theory classes we would have come across what do you mean by compression, what do you mean by decompressions, and what is this compactor. Just to have a quick review, like EDT is the integrated environment from the Tessent tool, which try to give a complete atmosphere on chip decompressor and a compactor. So what you could see here is you could see a decompressor over here, and one more is like a compressor, a compactor at the response side, right? So this complete environment, what we call it as an EDT. For any netlist, what you get out of the synthesis, need to be passed through an EDT environment, wherein this extra logic would be created, and thereby we will be having a complete EDT setup for testing, right? So let's see what is the advantage of it. First of all, it will reduce the test volume, it will reduce the test application time, and it could capture all fault and the patterns. It enhances the quality of testing, and it goes through simulated serial scan faster mode. Then what is its impact on the design? There won't be any impact on the design, as most of the hardwares are being added during the test mode, not on the functional mode. So no test logic is being added towards the functional mode, so you need not worry, it will not have a greater impact on it. But still, this extra logic has been added in the test mode, and it could create an extra overhead on the area, which will account to around 0.35% of chip area, right? So when you come to EDT, there are two types of EDT. One, you call it as an external EDT, and the other one is internal EDT. When I say, as the name implies, that external EDT and core will be situated here. Near to that you have an extra EDT logic. In this EDT you have a decompressor, a compactor, and an EDT bypass. This EDT bypass is an arrangement made in order to bypass this complete setup of decompressor and compactor. The reason to do this is, particularly during the point of diagnosis, you need to put all the scan chain in a single chain, and then bring it out all the response at the output. So whenever I need a bypass option, that could be provided by EDT bypass. So again, this EDT has a number of channel in and the channel out. By channel in, what do we mean here is, at the decompressor side, as we said, you can have n number of input and m number of output. This is called as the channel, EDT channel. So possibly it could be one, or you can even go with the multiple EDT channel, and the analysis need to be performed in the task. So at the last we would have given, like, go and make the channel to be 1, 2, and see what's happening. Remember, this is the scan channel, EDT channel, and these are the scan chains, right? Okay. Then again, this EDT has a clock, EDT has an update, EDT has an bypass signal. All this whole setup is being outside of this core, and this makes a top up, what you call it as EDT top. And for this core you will be having primary input, primary output, all this. When you come to internal, the core and the EDT logic is situated on the same core itself. Say this is module A, B of this core, and EDT logic is located here, and on top of that you have the complete EDT channel, signal, EDT out, signal, primary in, primary out. So so EDT becomes a part of this core, right? Next. So what else? The exact architecture has been shown. This is for mask controller, which we would have read in our compactor. In order to suppress the X entering into compactor, we use this mask controller. And coming to a decompressor side, you have decompressor and a bypass cell. This bypass will enable me to skip this decompressor and compactor. So core is situated inside. You have, when I say EDT, it will have decompressor and compactor. When I say bypass, then it will skip these two and get it out. So again, with respect to core, you will have the scan clock, scan enable, and these two the signals will be a part of this core. Whereas with respect to EDT, you have a EDT bypass signal, EDT channel, EDT clock, EDT update. These are the four signals which you have in addition to that. Now coming to decompressor type of architecture which we have discussed, like there are many type of starting from linear, broadcast mechanism. Ring generator is also one method of decompressor. Coming out to solve the problem with the ring generator, we have this phase shifter. Probably in the theory classes we would have come across all this. I am not getting into detail of all. Coming to compactor, we would have used different method of compaction, X compaction, all this. Again, XR based cells has been used for building up this compactor architecture. Now bypass architecture, here one point to be noticed here, because we are also going to do this as a task. So this is my channel in, EDT channel in, and these are my 4 scan chains. So what happens in a usual scan chain mode, there will be 4 scan chain and the 4 output will be passed on to the compactor, and finally you will get a channel out at this point, provided if this is under EDT. So EDT means one EDT channel, 4 scan chain. This will pass through 4 channel of scan flop chains and finally go to the compactor, and finally a single output comes in. When I say bypass logic, what happens here is this decompressor and compactor need to be bypassed, which means the channel 1 input comes over here and it goes through the chain 1 and then it comes roundabout, it goes roundabout and then enter into what you say again chain 2. Sorry, 1 minute. So it comes over here, you could see this comes and enter into scan chain 2, and again chain 2 goes over here and then come over here to chain 3. It's like a spiral loop. So come to scan chain 4 and finally it goes out. So what I mean to say is, bypass, you will have only one chain. All the scan chain would be looped into a single chain, and this probably helps a lot with respect to diagnosis. So we are going to do 2 type of analysis in our task also, one with bypass, other one with the EDT logic, and see what amount of data volume has been used and what is the compression ratio by applying EDT. Yes. How does the tool flow happens? So this is more important because this is how we are going to do this task. This task is bit lengthy because we are going to shift over from Tessent to Synopsys DC compiler and back to Tessent. So it's a bit lengthy, but the procedure is pretty simple, right? You first take a netlist. Here, as far as our task is concerned, we are going to use netlist.v, which is CPU netlist.v, right? So here we have this under the name netlist.v. You take this and you run insert scan. For insert scan, we are doing a scan insertion through scan.do file. So once we do this, you get 2 files which get generated out of it. One will be the ATPG script file, the other one is scan inserted netlist. So both the file will get generated after you run the scan.do file in the Tessent. Once you get these 2, you can go and again create an EDT logic. This is also a do file which is supposed to be executed using this scan insert netlist and the script, ATPG script, which has been generated out of running this scan.do file. Once you get this, then go to um, this EDT RTL and go for synthesizing it using Synopsys tool. So here the output of this EDT logic insertion has been fed as an input for synthesis, and we are synthesizing. Here we get this EDT graded script. All this will be taken as an input, and this synthesis in Synopsys will create an gate list, gate level netlist with EDT insertion. Now this will be passed to Tessent tool, and again test pattern generation .do file will be running up to generate the test pattern, and finally see what is the fault coverage. All these things happen using the pattern which has been generated. So the whole flow is, see, up to this Tessent, this is Tessent, and here it is Synopsys, and again this is Tessent. So we will do one by one this one. So what are the steps which we are going to follow? So for this, let's move on with one more file which I have made it. Maybe we will look into that. So this is our task, EDT insertion and data compression analysis. So what we are trying to say is we are going to insert an EDT, and we are also see what is with and without bypass, and find out the fault coverage, test vector compression, and test response compaction. So parallelly, let me open the tool and show you what is what. Before that, what I want you to do is, like, I have kept in the temp under the name lab 5 EDT. So you can just go to that location, copy that in your corresponding home location wherever you are, and then start doing this particular task which I am trying to do. So I am in my current location here in the folder test compression. Let me list out what is there in this. There are two important things, two folders, report and EDT. Beyond that, there is one one do file, scan.do, right? So let me open this scan.do and tell you what we are going to do. So this is my scan.do. In the scan.do, so this is the do file which I am going to run in the Tessent. So what is being set here, I am asking to put that in the scan mode, read verilog file netlist.v. This is the netlist file of a CPU which has been as an input for me. And one more, this is the DFT library file which you need to include. So two things are important. One is this library file, the other one is netlist.v. In the corresponding folder, I have kept this MDT file, that is DFT file also. So it is available in the same location. In case if you have kept somewhere else, give the corresponding location. Then set current design, then analyze mode, go for control signal auto, add black box auto, which means whenever you have memory or a macro, put them as a black box. Then report scan element, check design rules, DFT design rules. This line is more important. Add scan mode unwrapped chain count is 6. What we are trying to say is, see, you are going to configure 6 scan chain, and we tried to keep all the scan chains with the number of scan flip-flop almost balanced. With the total number of flop which we have it, we are going to divide them among 6 scan flop which will be available. Scan chain, 6 scan chain. Each scan chain might have 19 to 20 scan flop that we will see here. So accordingly, when I give 2 or 3 or 4, whatever scan count, after you run the script, you need to see whether the total number of flops has been almost equally distributed across all the scan chain count. Analyze the scan chain inside the test logic. These are some of the extra logic which has been added for the EDT testing. Report test logic, scan chain, scan cell, all this. Now the important thing is, out of running this do file, you will get two things. One, you get scan.v. This is scan inserted file. All the normal flop would have been replaced by scan flop. Second one is you will get an ATP zip file, that is scan Shakti or whatever name you give it, scan Shakti and dot do file will get generated for the procedure files which is used for ATPG testing, right? So again, these two will get generated in a folder called report. So make sure you create two folders. One is folder reports and another folder EDT. So these two are important. Um, so make sure in your location where you have kept your files like netlist.v, there itself you yourself create these two files, because once you run the script, these files scan.v and scan shakti .do file will get generated and deposited in the reports, right? Okay. So then in short, what I wish to say here is the scan.do is a script file. In that the input is netlist.v and an MDT file which is a library file, and the output is going to be scan.v file, scan inserted file, and another one is scan shakti.do file which will be available in the report. One thing that you can analyze by changing is change the scan count and keep on doing it, right? That's it. Now let's get back and see what else supposed to be done. That's what it has been said. So scan.do file, we are supposed to run that. Netlist.file I have shown you, and what is supposed to be done, library file is supposed to be done. I have kept this in the temp lab 5 EDT. These files are there, you can just take that. So create 6 scan chain. If you want, you can change that value and make your analysis. You need to create 2 folder, that is report and EDT. 2 files get generated, that is scan.v, and another one is one more is scan shakti.do file. One more do file will get generated in this. Now let us run this Tessent scan.do and see what it has created, right? Okay, now let's go back to the test environment. I'm just giving, okay, be in your current location, Tessent space sh minus do file. So here what I would like to run is scan.do file. So once I run this, yeah, what we could infer from this, let's quickly have a look at it, and you can have a detailed analysis on this. So what we do here is, so once I run this command, so what are the things that is getting, so it's going line by line, all this library, all the content. So yeah, this is what in the scan mode there are 6 scan chains, 0 to chain 5. So 6 scan chain would have been created, and the length of all that is 20, 29, like this, 19. It's almost balanced. So you need to change the value and see whether this chain has been balanced. What if there is an unbalance? Under unbalance, what happens is the lengthy chain, that many number of clock cycle will be required. So try to keep it as a balance so as to have the testing time to be less. Yes. Then so for every chain it has been given what are the connected flops. You could see all the flops are scan flop. Right. Now let me get out of it. So first do command is over. Now the next command is go for inserting EDT IP creation.do file. So let me just open this and show you what is there in this do file. Look at here. So set context is dft-edt, read verilog file scan.v. If you remember, the scan.v is the file which gets generated from scan.do, and of course you have this library file and all the other things are, and one more is scan shakti.do file which is there in the report. So this file and this file would be there in my report folder, it is taking that. And see, set EDT option channel 1. Channel 1 is like input towards a decompressor. So we have kept one channel, EDT channel, and 6 scan chain. Remember that. So DRC check, then go for EDT pin creation, all this, whatever that has been created, and one more lockup cells, lockup latch which has been created at the end of every scan chain in order to cope up the frequency of or the clock frequency between EDT and the scan chain. And to avoid the hold violation, the system include the lockup latch. So it will list out how many lockup latch has been included. That is also available there. Then write EDT file. Then out of this, it is going to create a file under the name created. Then whatever file that comes, it is going to get deposited in EDT. Remember, I asked you to create 2 folders. One is reports, the another one is EDT. Now in this EDT, it is going to create one more file that is going to be placed over there, and further on we are going to use that for for the further process of synthesis. So it's also reporting like create a pattern, report the scan volumes, all this. Now let's try to run that. Before that, let's see, is there any other point that need to be discussed over here? So so we are going to run this, what do you call it as EDT IP creation.do file. This is the second do file. First do file is scan.do. Now the second do file is EDT underscore IP creation.do. Right. So here we are just listing out what are the tools. Then there would be many files which would have been created in this EDT folder under the name starting with created. One such important file is created underscore dc underscore script.scr. So this file has the complete test procedure which need to be executed and need to be synthesized before executing the command of do file further for EDT testing, pattern generation. So we could open this file which will be available in this EDT folder, and one important thing which we need to do here is open this created dc .script file. In this script file you are expected to add few more libraries before synthesis. The libraries are the set search path, this particular library, and target library, all the target library, link library, and a few more like what are the variable set environment. All this need to be, this complete portion need to be added to this file which has been created in the EDT folder. So after inclusion it looks something like this. See, this complete thing has been included by opening this file, what you call as created underscore this file, created underscore dc underscore script file. So you could open it and add these lines, and I have kept all this path in .text file. You can copy that and append that with your dc underscore script. So let me see, let me run the second and see what's happening. Like yeah, let's, instead of scan.do, what we are going to do is EDT underscore IP creation.do. Yes. So we are going and creating the IP, EDT IP. So what's being said here? So you could see what is the test volume 5920, and what is the time, what is the fault coverage, the complete detail I want you to go through. What are the different types of fault due to simulation, fault due to implication, and redundant fault, ATPG, pattern generated, what is the fault coverage, the complete detail would be there. So you can just go through this, and you could also see what is the uh, yeah, what is this shift cycle required? It is 37. Why 37? 20 for internal scan chain, that is 20 is the maximum length, and 17 for additional clock cycles are required for initializing the EDT all this setup. So totally it requires 37 shift cycle. You can compare this with the bypass and see how much difference you have with respect to clock shift cycle. And the compression per pattern is 3.14x, and all the further details are giving max, masking bit is 7. All this has been given as an input. I want you to go through this line by line and see what is the information which you get out of this. Now see that there are 6 scan chain and the channel is only 1, right? Okay. Now let's see what is there in that EDT folder which has been created. Let me go here, EDT folder. In this EDT folder, see, you could see one created underscore dc underscore script dot scr. You can just open and see what is there in that. Now see here, without the library you would have see read files in the EDT. These files would have been created underscore core, created underscore EDT, created underscore EDT underscore top. These are the files would have been generated after you run the do file in the EDT. But beyond this, you need to add the library on top of this from the text file what I have kept. That 4 lines you need to add over here and keep it over and save it. And you need to copy. Cleanly listen here. Once you finish these 2 do file, copy this report and EDT folder to somewhere in your location, and these 2 folders are essential for synthesis. The complete folder, report and EDT need to be transferred to Synopsys tool. I believe up to this point it is clear. So you have run 2 do files and their outputs are there with reports and EDT folder. Now let us go with the Synopsys tool. So I am getting out of this Tessent tool and entering into my own Synopsys tool. Now we are in the Synopsys. I have kept this under the name lab 5. So let me list out. I have copied those 2 folder and place it over here. So whatever location which you want to work with in the Synopsys tool, you come and place it over here. So I have kept EDT and report folder over here. Now let me go with the EDT. The EDT, let me list out. See, you have many files which has been created out of the do file which you would have run in the Tessent. Now one important thing what we would like to see here is the file, that is script file, scr file. See, look at here, this dc underscore script. Now let me open and show you what is there in that also. So EDT, right. So this is my script file. Let me open with so that you could understand a bit more clear. Now see here, we have added these library. Following that, this read command, everything would be as it is. What is there in that? I think you might be knowing all this. It is reading one by one all the files and check timing specification, buffering. Most of the things are synthesis, right? Reporting the area, timing constraint, all this. And one important thing is, out of the synthesis, it is going to create me a file, created underscore EDT underscore top underscore get.b. This is the EDT inserted synthesized netlist, and it would be available in EDT folder in Synopsys tool. One important job what you need to do is copy this file alone, and you need to take it back to Tessent tool, right? This is the only file which you get out of synthesis, right? Now let me get back and let me run the command for it. So what you need to do is so for synthesis, DC underscore shell minus f EDT, then created DC underscore script. Run this and let's do that and see what's happening. First get out of EDT folder, then DC underscore shell minus f EDT, then created DC underscore shift dot scr. Yeah, so let me run this. Yeah, so you could see it is getting completely synthesized. I am not going line by line of the script. I want you to read and see what's happening. I am just getting out of this. Now I have received this created underscore EDT top underscore get.v. This is the netlist file after EDT insertion. Now I am going to quit this Synopsys tool. Remember, I want you to copy this file and bring it back to the Tessent. Now let us exit from here and let me again go with Tessent. CD VLSI, then so lab 5, then going on with testing, then with test compression. Right, now let me list out. Now see, let me go with the EDT. What we find here is, let me show you. So in the EDT we have this file, see, created EDT top underscore get.v. so this is the file what we would have received out of synthesis from Synopsys tool, that has been kept in this EDT. Now again get out of this EDT folder and run one more script file. What we have here is yeah, so this is EDT pattern generation. Now a complete netlist is there. Now go for running this EDT pattern gen.do. What is there in this? This is going to see, look at here. Now we are putting this in the pattern generation mode, scan mode, and the file which we give is created underscore EDT underscore top dot get, and this technology library for DFT, and we are asking to, we are also using created underscore EDT do file which would have created earlier. It's also available in EDT folder. Then we are asking to create patterns and report the scan volumes. And finally we are getting all the patterns in serial mode, parallel mode, ASCII mode, and the complete detail has been written in EDT folder itself. That's all. So I'm going to run EDT. Let me see, Tessent. Here it is EDT underscore pattern generation gen.do. So now this is the third do file which I am running in the Tessent. Now what is being said after this? See, number of clock cycle is 20 plus 17, which is 37 clock cycle. Number of channel is 1, and the volume of data is 6290. Remember all these values you need to compare. Now we have inserted EDT and we are getting all this data. We would like to compare without having EDT, what will happen, right? Now here the fault coverage, for number of fault, effectiveness, time it takes, what are the fault which comes under undriven EDT blocks, all this complete detail you need to go through and analyze, have all this information, because these are the information which will be useful for comparing with the EDT and with bypass. So the same details you are getting, and the number of shift cycle is 37, the longest chain range, every detail is being given. Again, you go through this complete detail, take into account, and uh, and you can go through what are the scan chains you have, all this. And you would also see there are so in the previous case you would be lockup latches would have been inserted, that is also there. Number of transparent latches 6, so you could also get the list of transparent latch, that should also be compared. So these are the metrics for comparison, and in the previous synthesis also you will get that report, what are the lockup latches which has been inserted. Okay, so using this information you are supposed to now compare on the basis of what is the test volume, what is the pattern, what many clock cycles, all these details. Okay, that's all. Now this is over, but what I would like to show one more is what would happen if we don't insert an EDT, or we are going to bypass this EDT. If that is the case, the same procedure, I am going to run one more file. Look at here, scan without EDT. Let me open and show you here. All the context all are almost same as scan.do file, except the scan count, chain count is 1. So which means the whole flops is going to get connected as a spiral fashion as a single chain. So there is no EDT insertion, that is decompression and the compaction, and the whole flops are going to be connected as a single chain. Yes, so this is the important change which we make it. Now we will run this. When I try to run this, let's see. Now you remember this count 6290, this is the volume after you insert the EDT. Now let me run this scan without EDT. Now the point to be noted here is, see, all the flops has been converted to scan flop, but let's see how many scan chain. The channel is 1. Oh, that's from the previous. This is from here. Okay. CPU time, auto, again it is taking, see, number of memory element is 116, sequential depth is 116, and library is this one. Top level, add instant retiming, add scan chain count, see, it's only 1, so we have kept 1. The scan chain count is also 1. So previously we had 6 scan chain in EDT insertion. Of course you can keep on changing based upon the task which has been given to you. What is the length? You see 116, I mean 116 is the length, which means that many number of clock cycle, whereas in the previous case it is just 20 plus 17, it is 37. So these are the parameters which you need to look in and make a cross comparison and make an analysis on it. Right. Next, let me go and run this now. You have made a scan.2. Let me run one more on the scan, creating patterns for it. Now I am using this atpg_1 do file. In this, the input is scan without edt.v. This will get created and deposited in the report folder, and of course all the other things, like previously we used to have scan.v, no, like that we have now asked that to be deposited as scan without edt.v, right? And one more do file, scan Shakti without edt.do file. These two will be there in the reports, and you are asking to create a pattern and see what is the scan volume. Now let's run this do file. So Tessent, yeah, I'm going to run this atpg.do file. Now the important thing what we would like to do is the scan chain, scan load is only 1, and the volume, I mean this clock cycle will be 1116. Look at the volume, it is 18,096. Our previous case was around somewhere around 6,000, so it 5,000 something. So here it is 18,096. It's around 3 point some x time 3.1 or something like that. That is the compaction ratio which you get out of going with EDT. Now I think you could understand. Now you could also see what are the faults, total number of faults, comparing that with the EDT insertion. What is that? What is the fault coverage? How much scan shift cycle you require? What is the compression ratio which you get? All this you need to make a detailed study out of this, and you could also see the lockup latches which would have been generated. That also you can see. So please go through the report line by line and make a comparison of all this study. See lockup latches which would have been created. So it will also list out the lockup latches also, which is supposed to maintain the frequency and avoid the hold violation. Yeah. So that's all. So this complete process, I believe it will take you through the whole idea of EDT insertion and bypass technique. What is the process of how do we calculate the compaction ratio? Every whole detail you can get it. Now let me finish this, and what you are expected to do in this case, see, we ask you to run these two files atpg. These two files are without scan chain, bypass, without EDT, right? The corresponding file name has also been created. You have been asked to test these two, and what are you supposed to compare and report? You need to go with all what are mean by lockup latches, how many lockup latches has been added in the design, what are they, why it is added. This study would need to be made, and there is a PDF file from the Tessent manual. I want you to go with this compression, complete PDF manual, so that you will have much more clarity on further on EDT. Since the core level scan chain will not be connected to the cloud, where does the scan input pins are set to, scan output pins are set to what are the violations while inserting EDT, and you are supposed to make these following changes: 1 EDT channel, 20 scan chain, 3 EDT channel, 20 scan chain, 2 input channels, 1 output channel, So what on doing all this, you need to report the shift cycle, report the pattern count, report the fault coverage, report the data compression in each cases. So if you could finish all this, I believe this would give you a comprehensive idea about a complete EDT insertion process, as well as knowledge about the EDT and without EDT, that is bypass EDT. Right. So I have kept in the temp a folder which is under the name. I will also show that. So I have kept like /temp. I have kept lab5 EDT. In that I have kept the netlist scan.do, then scan EDT IP creation.do, EDT pattern generation.do. This library location, those 4 library I have given here, you can copy and make a corresponding change in the script file. And these scan without EDT and ATPG1.do file, these two are for bypass, and this is the library file, and this is the test compression, which is the PDF which I have kept, and of course one more PDF is also there. I will also keep it, so you can read the complete details about the EDT. I want you to stick on with the timing, whatever which we have mentioned. Go and read and do this task. Make sure you make a report properly and update that in the VTOP. See you, bye. Thank you. See you in the next task. Bye.